Hey everyone, happy Halloween and welcome back to another Mu Alpha Theta video. This one is for IM2 U2S4 Standard 4 Pre-test self-assessment, and we're going to be reviewing some questions that I think are super important to review. So yeah, let's go ahead and get into the video. Alrighty guys, so here we're looking at question 8. Oh, that was a really bad circle. Question 8. Okay, so this question says the equation g of t, all of that, represents the height in feet of a grapefruit. So we can just go ahead and note that g of t represents height of grapefruit. Okay, and then, yeah, a grapefruit t seconds after it has been launched. So this is after it's launched. Then a grape was also launched at the same time, and its trajectory is modeled by O of t. So I can just label this orange. Now that we have that, let's look at our first question, right? What is our first question asking us? So A asks, which fruit reached a higher height and how do you know? So here's something that we're looking at. We can see, well, we understand that these are both quadratic functions, right? The way we know that is because obviously it's here, it's coming up by a constant value and then it's coming down. So we know a quadratic function is going to be parabolic. Okay, and so with the quadratic function, its vertex point is always either going to be its minimum or its maximum. So I would say that our first step is to actually find our vertex point. So on g of t, our vertex point is about like right here. And that value, what in the world? That value is 25,164. So this just says at 25 seconds, it has reached a height of 164 feet. Now, our vertex here is going to be, well, since you can't like physically see it on the graph, we can just look at the table. So we have to we can notice a pattern that it's going up, and then suddenly it gets to this number right here. Oh, that was really ugly. Okay, suddenly it gets to this number right here, and then it just goes back down, right? These two are symmetrical. So we can actually kind of assume, like, if you want to finish this table, I would recommend you finish this table. We know that it's just going to go back down symmetrically. So this next value is going to be 80, and then 0, then 5, 6. Yeah. So yeah, we just continue the table symmetrically. So here we see that the highest point, or the highest height in feet that it reaches is 144. So we can label this, all of this, our vertex. So since our vertex point is 3,144, this means that after 3 seconds of being launched, it has reached 144 feet. And then it continues to go back down. So what this means is that the highest height that g of t reached, the highest height that g of t reached was 164 feet before it went back down towards the ground. The vertex point of O of t is saying that the highest height that it reached before hitting the ground was 144. So this is before it started going right back down. That's this point right there. So the way this is going to help us answer question A is that now that we know the max height of each of these functions, we can just straight up compare the numbers. So if the max height that it reached for g of t was 164, we know 164 is greater than 144, which is the max height that O of t reached. So we can answer this question real quick. We can just say, we can just say the grapefruit reached a max height of 164 feet. And then we could just say the orange reached only 144 feet. I'll probably rewrite that, but not at the moment. Actually, no, I'll rewrite that. Okay, guys, now doesn't that look so much better? Anyways, on to the next question, B. Which fruit landed first? Okay, you guys might be able to like understand this quickly, but when I was doing this, I could not understand for the life of me what that meant. So what that is like technically saying, or what that's trying to say, is you're just trying to find when is y equal to 0. So literally, like, you could even solve this algebraically. Since we actually have this equation here, we could just say like when g of t is 0 is equal to all of this, and then find out what t is. You could do that, obviously, or you could just look at the table. Or you could just look at the graph. So we can actually just look right here, and this little point is when y is equal to 0, right? Yeah, when y is equal to 0, it's this little point right here. And I would say this point is about like 50, yeah. Sorry, let me just change my color. I would say this point is about like 5.7, 0. Yeah, because that is when it hits the ground. And then thankfully, since we filled in our table earlier, we are actually able to like see this really quickly. So when y is equal to 0, it had been 6 seconds since it launched. Oh my goodness. So what we really wanted to find was when y was going to equal 0. So we can like, for the sake of like logic per se, this graph doesn't really count at all, because you're not going to go back in time, if that makes sense. You can't just go back in time. So we can literally just like ignore this for time's sake. And we're just looking for when it's going to hit the ground, which means when our output is equal to 0, because our output is the height. So for g of t, the grapefruit reaches the ground at 5.7 seconds. And for O of t, the orange reaches the ground at 6 seconds. So we can just say that the grapefruit landed first because it landed after 5.7 seconds, and which we can see right here. And the orange had landed after 6 seconds. So obviously we know that it was the grapefruit that landed first. Okay guys, so question 9 says, the choir sells baked goods to make money for their trips. They found out their revenue, which is their money earned, changes according to the price they charge per item and can be modeled by the following equation, where x represents the price per item and 20.5 minus x represents the number of items sold in thousands. Okay, so our first question right here is A, and it asks, how do you know that r of x is quadratic? Now, how do we know that this little guy is quadratic? So the way we know this is because we can actually distribute the 2, and that gets us to an x squared. Like, we don't even have to fully distribute. Well, actually, we are going to fully distribute. Let's do that. So x times 2.2, that's 2.2x, and then x times x is just minus x squared. So as you guys can see, what in the world? Okay, as you guys can see, we have an x squared right there, and that's how we know it's going to be quadratic. Because a quadratic is a polynomial function. Actually, let me write that down. So a quadratic function, I don't know if you all remember this, it is a polynomial with a degree of 2. Okay, so for our explanation for A, we can just say that it is quadratic because it is a polynomial function with a degree of 2. That's our degree of 2 right there. Now, question B asks, for what values of x would the choir make no money and why? So since we know this is a quadratic function, we know that it's going to be parabolic. And we can kind of like assume that it is definitely not going to look like this. And most likely the graph is going to end up looking like that. So we can like mimic a graph. Not mimic a graph. We can actually like sketch a little graph that would mimic this equation. So we already know it's going to do something like that. And we know that literally if they sell nothing, they will make no money. So we can always write down 0, 0 as 1, because that's just saying for 0 items that they sell, they make 0 like revenue, which makes sense. And now really what we're trying to find is this other dot right there. And the way we can do that is we can actually solve algebraically. We can use our equation over here and make it equal to 0. And the other place where we can actually find this is from our little graph, not our graph, from our equation right here. So our equation right there says r of x is equal to x times 2.2 minus x. So this is the same thing as this equation just factored out. So this, I don't know if you guys noticed, this is our factored out equation of this. So we can like use this little equation, and what we're trying to find is when is y going to be equal to 0, right? Like when are we going to intercept with the x-axis, which is going to be when y is equal to 0. So the way we can actually find this is what is going to make this little section 0. And we know that to cancel out 2.2, we need to add 2.2. So we know one way we can make y equal to 0 is by having x be equal to 2.2. Or there's this little x right here. And the way we can eliminate that is just by having a 0 right there. So another option would be having x equal to 0. So when x is equal to 0 and when x is equal to 2.2, so this would be 2.2, comma 0, then the choir would make no money, because the money they make is represented by the output, which is y. So when the x value is 2.2 or 0, the y value will be 0 and 0. And if you want to like see that actually done mathematically, let's say we replace 2.2 for the x's, 2.2 times 2.2 minus 2.2. Yeah, I'll just put a parenthesis over the x's so you can visually see that. That's going to make it 0. Anything times 0 is 0. So if we were to plug in 2.2 for the x, we would get y is equal to 0. If we plug in 0 for the x, it's going to be 0 times 2.2, which is 0. So that was just asking us if we knew what the x values needed to be in order to make the y value 0, because the y value represents how much money the choir makes. And if they make no money, then y would be equal to 0. Okay, now on to question C. It's asking how much should the choir charge if they want to maximize the revenue. So this is also where you kind of have to get to thinking, because when you read this question, at least personally, I'm like, how am I supposed to figure this out, right? But let's think about it real quick, right? If we understand that this equation, or like the equation to find the revenue earned by the choir, is quadratic, right? Since it's quadratic, we know we are going to have a parabolic shape. And the quadratic function is going to have a vertex. And in that vertex, it's going to represent our maximum. So our vertex should be somewhere here, right? And we thankfully already know our two x-intercepts, which is 0, 0, and 2.2, 0. Those are our two x-intercepts, right? And what we're trying to figure out is what is our vertex point here, right? Because our vertex point here is going to represent our maximum. So the way we can actually find that is, if you remember, our vertex point for a quadratic function is also the point of symmetry. So we could actually just find what the x value is for the middle of these two values. So, you know, if we have 0, 0, and we have 22 point, I keep saying 22. We have 2.2, 0. We need to find the middle between these two values, which is 1.1. That is half of these two values. So the x value of our vertex should be 1.1, and we can find the y value by plugging in 1.1 for this equation right here. So I'm just going to plug that in. Just going to plug in 1.1 times 2.2 minus 1.1. That point isn't okay. Anyways, that is going to get us to 1.21. Let's make sure we add in that r of 1.1 so you know what why did I put an f? Okay, let me put r 1.1 so you understand that we're inputting 1.1 as our x values. Yeah. So X represents the price per item. So that means whatever we're inputting, in this case is 1.1, that is the price of the item, and what we get out is how much revenue they make. So the best way they should charge their items is 1.1, I guess, dollars. I don't know. I don't think it gives me a unit, but just know it's 1.1, which will ultimately leave us with, or leave the choir with 1.21 thousand. Okay, guys, we're in the home stretch, so stick with me. Let's move on to question D. And question D asks, the choir needs to make at least $1,000. Well, guys, I need $1,000. For what values of X will they hit their goal? You should use your graphing calculator to answer this. They will make at least 1,000 if they charge from blank to blank. So I can't really show you guys how I would plug this into my calculator, but I can explain it to you. I can help you guys break down the question so you can do it in your calculator. So my first step would be to actually plug this entire thing in. Well, actually I wouldn't plug this in. I would rather plug in this. So in your calculator you would write f of x is equal to 2.2x minus x squared. And once you plug that into your calculator, you should get what we've been getting for the past other questions. You should get something with 0, 0 here, 2.2, 0 here, and 1.1, 1.21, somewhere in that vertex. The choir needs to make more than $1,000, right? So we're trying to find the X values for when they hit that goal. My suggestion would be to figure out, through your graphing calculator, when Y is equal to 1. And you're like, why would we do that, right? Here's the thing, guys. We're doing these in thousands, right? So when I'm saying Y is equal to 1, I'm saying when it hits 1,000, right? Because our Y-axis is scaled, smaller, if that makes sense. It's supposed to be representing thousands. So we want to figure out when Y is equal to 1. And the way you could actually do that is you could actually input a whole other equation that just says I would say F2 of X is equal to 1. And that's going to create, a little line that's going to go right through, let's say this is where 1 is at. That's going to go right through Y equals 1. That's what it's going to look like. And wherever it intersects, let's say it's going to intersect here and here, those values are going to be the X values for when they will hit their goal. And I actually did plug this into my calculator, and I got 0.641 and 1.55. Yeah, that's what I got. And obviously it has has a Y value of 1 because we made this line Y is equal to 1. And so really all we care about is our X values here. So that just means that they will make at least $1,000 if they charge anywhere from $0.64 to $1.55. So just to review what that last question was asking, because I feel like it might have been a little complicated, we need something that makes $1,000. That means we need some kind of points that intersect when Y is equal to 1, because Y being equal to 1 just represents $1,000. So once we plug in this equation into our graphing calculator, we can just figure out where Y equals 1 intersects with our R of X, and that is going to give you the X values, right? We're looking for the X values of when they will make at least $1,000. And from our calculator, we got 0.64 to 1.55. Yep, and that's it for question 9.
Alrighty guys, that's it for this week's video. I really hope you enjoyed that. Please, if you have any questions, leave them in the comments, ask one of your teachers, or sign up for Mu Alpha Theta tutoring, because we are always happy to help you guys. Thank you guys so much, and I hope you guys have a great rest of your day.
Oh, and don't forget to like and subscribe. Please.